Hello and welcome to the AWS reInvent presentation of RAG and Route, Enhancing Networks to Support Amazon Bedrock. I am Tim McConaughey. I am a technical marketing engineer here at Aviatrix. Before here, I worked at Cisco, and I have a CCIE certification and an AWS Advanced Networking Specialty certification. I'm also the author and co-author of a few books based on AWS. The Hybrid Cloud Handbook for AWS, that's mine. And the AWS Advanced Networking Certification Guide, that's going to be published through Pact Publishing. I also have a blog and a YouTube channel under the name Carpe Diem VPN. Now, for the agenda, let's just roll right into it. What we're going to talk today about is RAG, which is Retrieval Augmented Generation. We're going to talk about basically what is RAG, how does it fit into the larger AI workload LLM model, and then we'll talk about Amazon Bedrock, which is a front end for interacting with foundational models through Amazon. We'll then talk about the networking challenges of disaggregating a RAG solution. And of course, one of the possible solutions that we want to introduce is the Aviatrix Secure High Performance Data Center Edge for LLM. So what is retrieval augmented generation? Well, the first thing is, of course, now by this point, everybody has probably had time to play with ChatGPT, Claude, different foundational models with a chat interface. And so they should be fairly used to large language models, or at least understand what a large language model is and how you interact with it. But of course, for those of us who are old enough to remember, it's very much like an original large language model. So in my opinion, printed encyclopedias were the real first large language models. So they were, for those of us who are old enough to remember, they were like door-to-door salesmen or salespeople would come to your house, convince your mom that you need your parent that you need an encyclopedia, a set of encyclopedias to excel in school. And so they would, sell a whole, just a bunch of these encyclopedias, usually as a set. So these encyclopedias had all sorts of facts in them. So it was kind of like a general fact compilation of a lot of different facts and figures, details. The agency or the company that ran that compiled the encyclopedia together would use specific sources to pull all of that data together, put it through the bookbinding process, organize it, put it in in order, A through Z. And by the time it got to you, and by the time you were ready to use it for a book report, this kind of original LLM was mostly already out of date, which is to say some of the facts and figures, a lot of the details in there were already out of date by the time you were ready to use them. So how do we solve that problem? Well, that's where the original RAG comes in. And sorry for the dad joke, but we used to call magazines RAGs back in the day. And so the idea of a magazine being a complementary product to the large language model or the encyclopedia. So, back when you would do, say, a book report on dinosaurs or something like this, it was very, very common to start with the encyclopedia, open the encyclopedia up, start getting details about, say the T-Rex or something like this, whatever you're writing about. But, again, by the time you're reading this encyclopedia, back when I was a kid, there was new stuff coming out about dinosaurs, it seemed like all the time. So, for example, like National Geographic or one of those type of publications were regularly printing new fossil findings or new paleontology findings about T-Rex. So if you as a student are writing a book report on your T-Rex, this was information that you wanted to get into the report. You wanted to be up to date. You want the most recent, most correct version of data to be part of the output in this case, which of course was a book report. So what you would do is you would use these magazines to help you augment the information, more up-to-date information than you could find in your encyclopedia. So let's go through the elements, or rather through the abbreviation RAG, right? So retrieval is the R in RAG, obviously, and this has to do with the act of fetching relevant content for the prompt or query from the knowledge base or whatever data source that you are using based on the content of the prompt or query that you're making. So again, in book report terms, this would be, I want to write a book report about T-Rex. And so, you're going to go look, you're going to want to retrieve the relevant data about the T-Rex, the most up-to-date info from, say, you've got, 10, 12 magazines sitting around. You obviously want to retrieve information about T-Rex from the magazines that matter. You don't want to, you're going to use something like National Geographic. You don't want to spend your time looking through, Teen Beat or something like that. From an augmentation perspective, which is of course the augmentation has to do with taking that relevant context that you pull from the data source or knowledge base, and then you add it to your original query, your original prompt, and you're going to enrich that prompt with more up-to-date information than the model has, and it's going to help add context and just make the prompt better with more information. And that custom data enrichment helps refine the prompt. And so when you've refined the prompt, added extra context, you're going to get a better response. And then, of course, the G is for generation, retrieval augmented generation. And so the generation has to do with the generative AI response that you're going to get back from the foundational model. It's going to be enriched by that extra content. It's going to be more relevant. So whatever is coming out of that language model as a prompt reply, whatever that output looks like, it's going to be more timely. It's going to be more correct. Okay, so that's the high level. What does RAG do? Let's get into kind of the details of how the RAG works, and then what you'll see is as we go through it, we'll get to the networking part of it, because the networking part of it is very much a big part of how we're going to connect all the pieces together. So the first thing we start with, of course, is just some kind of document source, whether it be a PDF, an order form, some CRM application that has data for your customers. Depending on what you're doing, it's going to be a document of some kind that has relevant data, and you're going to load that into your data source. And your data source could be, it could be an S3 bucket in Amazon. It could be a managed service like FSxN for NetApp ONTAP. It could be on-prem. It could just be an NFS file store. Anywhere you can store data in a relevant context, that's what you're going to do. Now, the middle part of this process is the embedding model. The embedding model is kind of like an AI model, just like the LLMs, but it was trained on the ability to pull apart relevant info and group it together into the process called chunking. So it takes that document or documents, and it actually runs essentially a mathematical algorithm on that data, and it turns it into little chunks of data, and it groups those little chunks of data together in a way that is hopefully relevant, hopefully has the right amount of information. Like if it was a sentence, it might pull a whole sentence. It might pull just pieces of data together for relevant context. And it turns them into what's called vectors. And the vectors are mathematical representations of the data. And again, this is done using stuff that's way above my head. But they use math to turn the data into a vector. They load the vector into a vector database. And then, of course, the vector database has this index where you have the vector math and the chunks of data that you're going to want to reference later. And so this is all part of making the RAG process consumable and quick. Now let's put RAG in context of an actual AI workflow. So again, we're going to run through the same steps. We're going to load the document into the data source. We're going to use from the data source, we're going to use the embedding model to chunk that data into pieces. And then once it's done, it's going to load that into the vector database. Okay, so that's what we just talked about. Now, let's add in the rest of the pipeline. So here's a user query, whether it be via chat window, whether it be via API, some application, AI agent, whatever that looks like, some sort of query is generated, and that is actually also put through an embedding model. Now, what's important is that these two embedding models, they don't have to be the exact same workload, the exact same device, or anything like that, right? But the embedding model itself needs to match. So what that means is think of it like a decoder ring, encoder decoder ring, or something like this. The embedding model matches on both sides so that when you chunk the data, you get the same vectors. And this is important because the next step of the process is that the output of that query, vector output of that query, is going to be compared against the vector database of all the documents. And so there's going to be what's called a similarity search. And so they're going to search for similarity, and vectors that are similar to some degree that's configurable, how loose, how wide that might be, it's going to start returning data. And using that data based on the vector search, it's going to augment the prompt. So that original query is going to have this extra context, this more timely information is going to be added to that prompt. And that whole prompt is what actually is going to be ultimately sent to the large language model. And so based on that information, the reply is going to be the output, the generative output, whether it be a document, a video, picture, whatever that is, right? The prompt that goes in and the data that comes out will be better based on that contextualizing of the data. All right, so now you understand basically how RAG fits into the pipeline. Let's talk about Amazon's kind of AI front end, if you will, called Amazon Bedrock. So Amazon Bedrock is a fully managed service, and what it does is it front ends a lot of high-performing foundational models from all the leading AI companies, Claude, OpenAI, or ChatGPT, OpenAI, all of them. And then what AMS is doing for you is that it's providing an API up front to interact with these models. So the product, if you will, with Bedrock is the API. The Bedrock API is the method by which we're sending queries to the foundational model. And as part of that workflow, Bedrock allows us to use RAG to enrich those queries for better results. So, it has other things. You can build AI agents, and it has multiple AI capabilities, but we're focused on this. What is Bedrock doing in the pipeline we're talking about? Bedrock is that API front end. So you're not sitting there in a chat window typing, I need to know about T-Rex or something like this. It's really an API. So it's really application focused so that you can send API calls, and the API then interacts with the backend foundational models and returns the information to you. Now they have something called knowledge base. This is a specific to Bedrock thing. The Bedrock knowledge base is just a managed solution. So RAG, as you can imagine, given all the pieces of RAG can be quite complex. And so a knowledge base is a fully managed RAG solution. It's based on a set of predefined data, data sources, and embedding model options. Now, what that means is that the knowledge base is you kind of pick what you're going to, there's like drop downs and whatnot in the AWS console that when you create your knowledge base, you're choosing what is the embedding model I'm going to use? What is the data source I'm going to use? What is the vector database I'm going to use? And so you choose from a predefined list, and that's how the knowledge base works. And because you're doing this, you don't have to set any of this up yourself. So that may fit a large number of people who want to get into and start using Bedrock as a solution, but there may be an equally large number of people that can't use that managed solution. So enterprises are also able to create and maintain their own RAG solution, and they can still use Amazon Bedrock. So it's not required to use a knowledge base to use Bedrock, right? They offer it as a managed solution. Hey, we can do RAG for you and build it into Bedrock, and here's how you do it. But you as a business may have some reason that you're not able to do that or don't want to do that, right? So the data source for your own managed solution could be on-prem, it could be another cloud, it could be an AWS FSxN, NetApp for ONTAP, it could be an S3 bucket, it could be a combination of these things. Your embedding model, you can run pretty much anywhere you can have a workload that uses this embedding model to chunk that data and put it into your RAG pipeline, as part of the augmentation pipeline. And then, of course, vector databases are not unique to AI workloads, right? Vector databases have existed, and they can exist anywhere you can put a database. So you can use OpenSearch, AWS OpenSearch, you can use on-prem, support a database solution, whatever, another cloud. So obviously, if you're going to do something like that yourself, there are some networking challenges to overcome, because what we're talking about is pieces of a solution. And when you have pieces of a solution, you have a need to connect those pieces. And especially in terms of putting data into a data source and having it part of this pipeline. So building a RAG solution pipeline requires three major things, right? The first one is, of course, the security of your data in transit. You have to be, the data that you are putting into your data source, or even ultimately using as part of your pipeline, is usually going to be proprietary data. It's going to be something that's very, very specific to the thing you're trying to do. And that could be proprietary business data that you don't want getting out. The other thing you need is timeliness of data delivery. So if your solution is based on up-to-date information, excuse me, you need that information to be quick. You need it to be quick. You need to be timely. You need it to not be something that's going to be uploaded 4 hours from now when you need the result now. And then, of course, depending on your requirements, you may need to regularly refresh that data to keep it current. So this one's very specific on requirements. Like if you think perhaps there's, to give you an example, there might be like an AI agent or something that's watching a trending of your application, and as customers are calling into the call center, we're logging how many customers are having a specific problem with a specific part of the application, right? And that AI agent is collecting that. And so if you want to be able to react quickly, you want that information from your customer to be very, very current, so that you can find that trend with your AI agent. And this is just an example, of course, right? There's a million examples, but regular refresh to keep that information current could be part of something that you need. So one easy way to solve for this is Amazon S3. So the S3 bucket, the old, data storage in Amazon. So S3 buckets tick all the boxes to some degree, right? So first of all, obviously S3 buckets have TLS encryption for security. And that means right off the bat that we can use application layer security for S3. And so we don't need to worry about, get different legs of encryption. We can just do it straight at the app layer using TLS. That's a well-known and well-trusted encryption method. S3 could also serve as a data store for Amazon Bedrock knowledge bases or your own custom RAG solution. So that means, if you decide to go with a knowledge base, obviously you can just pick it right out of the dropdown. If you decide to build your own solution, you could still, not pick it out of the dropdown, of course, but build it into your RAG pipeline. And to answer the timeliness bit of the data delivery, S3 supports things like transfer acceleration, multi-part upload, and of course you can always use a direct connect with a public virtual interface that connects to AWS's public zone and gives you 10 gig or higher connectivity to S3 directly from your on-prem location, right, or your middle mile location. And of course, from a refresh perspective, keeping your data refreshed is as simple as scheduling your data transfers into S3. Now, if we're moving data to S3, where is it coming from? So remember, your data source could be literally anywhere. Anywhere you've got data, you could be moving it. So you could be moving it from other AWS regions and VPCs, in which case most likely you're going to use something like an S3 gateway in that VPC and just use Amazon's backbone, essentially, to send that data straight into the S3 bucket. You could be coming from on-premises, in which case, like I said, you could be using Direct Connect, using AWS's public zone, a public VIF, and connecting straight to S3 over your Direct Connect. Or you could be coming from other clouds. If you're coming from other clouds, there's multiple options, but obviously the simplest and easiest one is that you are using just an internet connection, right? Because S3 is a public service. You can access it, it's web layer type stuff. You can transfer data from anywhere to S3 over the internet. So that's generally what you'll see coming from other clouds. There are some drawbacks, and there might be reasons why you as a business might not be using S3 or might not be able to use S3 for a RAG pipeline. So first of all, transfer acceleration, direct connect with public VIF, they cost money, right? Convenience costs money, and you're going to find that the same the whole world round. Sensitive data is safe in S3, but there are regulated industries that do restrict and actually keep you from, putting certain types of data in S3. So it just depends on the industry, all the governance and whatnot that you need to deal with. I was going to say certifications, but just the policies in place. So you may not be able to put those in S3. And then, of course, in terms of regular refresh and replacement of data, this is actually one of the things where S3 might really be a bad choice, depending on your needs, because regular refresh, regular replacement transactions with S3 could potentially, balloon in cost very quickly, depending on what you're trying to do. So there are reasons that businesses choose not to use S3 as their data source, and those are just a few of them. All right, so let's talk about bringing your own RAG or building your own RAG, depending on how you want to do it. So when you're bringing or building your own RAG, kind of the sky's the limit, right? You have certain elements of it that need to exist for RAG to be RAG, if you will. But beyond that, as long as they meet those requirements, you can pretty much use RAG with any solution. It doesn't have to be Bedrock, you can be using it with anything any AI workload that has the ability to utilize a RAG. So some of the options, right? So we could use AWS native services, like for the vector database, there's Amazon OpenSearch. I believe that is even in one of the choices for knowledge base. You could use a third-party solution, like I've just listed Pinecone here, but there's multiple third-party vector database options that you could run on your own or as a service. Or you could even use another cloud service. What if your main cloud is Azure, but you have a need to leverage Bedrock for some reason, right? You might have everything sitting in Azure, or at least you might be using Azure, cognitive services for some other purpose. You can still use it and use Amazon and use Bedrock as well. So from an embedding model perspective, AWS offers the Amazon Titan embedding models, but there are third-party embedding models, and of course there are embedding models that exist in other clouds. And the embedding models are really, really tricky because each embedding model is trained a certain way to chunk data a certain way, and that means what's good for one company may not be good for every company. And this could be a reason that drives you not to use knowledge bases potentially. There are several embedding models, and it's very likely that you would be able to use it. But you're trusted to know your own business and to know what's needed. So choosing a different embedding model might be a very good reason why you can't go with the knowledge base solution. And then from a data source perspective, you could use the Amazon managed data source, like say FSX for NetApp ONTAP as an example. You could use the on-prem NetApp, and I've said NetApp twice, so let me be clear. NetApp is just one option, right? You can pretty much use any file store or file system you have. The point is that it's a data source where we can pull this data from to be part of this RAG pipeline. Or of course, you could use cloud storage in another cloud. All of these things are possible if you're going to bring your own RAG solution, and if you want to have the freedom to build your own RAG pipeline and utilize data where it makes sense to you. All right, so this begs a very important question for the network engineers in us. If our RAG elements could be anywhere, so how do we keep it all connected and secure? The network engineers are already probably sweating the idea of pulling this apart and doing it. So, let's talk about the way that Aviatrix suggests that we build a network that can support a data is everywhere type of solution. All right, so just this talk obviously is not a sales pitch, but I think it's important that we cover what Aviatrix is and what it does, so that so that we can then get into how Aviatrix can solve a disaggregated RAG solution. Because if you don't understand what Aviatrix does, it's going to be really hard to explain how Aviatrix actually helps in this particular setup. So we simplify operations. That's a big one. This means that we give you the options. We're very big on giving customers the option to build where they want to build in any cloud they want to build, and of course using hybrid cloud as well. And giving, despite where you as a customer choose to build, we give you operational consistency. And of course, as part of the package, we give you advanced visibility on top of that. Because Aviatrix becomes part of the data plane, we can do that. And because we're part of the data plane, we can also offer improved security. That's embedded as part of the data plane. So we can now enforce where we also network. That gives us really unparalleled ability to centralize a policy of security, but distribute the enforcement of security across your entire network, cloud network, hybrid network up to a certain point, of course. And not everyone saves a ton of money using Aviatrix, but we have a very good architecture that, for a lot of customers, offers savings, reduced costs on certain things. Especially things like egress spend, certain network costs. There's some efficiency that can be found, depending on, of course, the customer and their architecture. All right, so I mentioned we have the secure global LLM, the use case. So high level, what we're talking about is the ability to connect your on-prem or other cloud locations, your data, your embedding models, your vector databases, your data source, anything can live anywhere, and Aviatrix is able to connect all of those pieces together so that you can build the AI solution pipeline that is right for your business, and not have to be concerned about how to connect all of the elements of that pipeline together. So secure global connectivity, we potentially can reduce operational costs. Superior resilience is a very big part of what we do. So that's, I'll just move on. Basic idea is that we offer a solution for customers that are in one cloud, multiple clouds, and of course, hybrid cloud connectivity. And we offer the same control and experience across all of those, right? You get the same agile experience, any cloud, any carrier, any location, wherever you are, you connect Aviatrix together and you get the same experience for your applications, right? So unify the control and data plane across multiple vendors. And that means control it from one place, see it from one place, troubleshoot it from one place, and trust that your data plane is one data plane, so that we're not dropping data anywhere. So because we do that, you get observability to the data plane. So supporting RAG with on-prem data sources, right? So we've talked about how elements of a RAG can be disaggregated. And what we mean by disaggregated, of course, is that we talked about how we have the data source, we have the embedding model, and we have a vector database. And then ultimately we have, the LLM, the actual large language model that we're trying to interact with by enriching the prompt with our RAG pipeline. So with all of these pieces, we can disaggregate at least the parts of the RAG and ultimately where we interact with the LLM. And so that means that we can locate all of the elements wherever it's most advantageous for the business, or depending on where your governance and policy dictate that those things be added. A lot of times customers have started in one cloud, they've spread to multiple clouds, and for whatever reason, the gravity of data might not be in the same place where they want to interact with a large language model, consume a service, like, for example, Amazon Bedrock, or AWS Bedrock, rather. But they might have already built some front-end information that they want to use elsewhere. They might have built an embedding model in Google Cloud because they were using something, or they were beta testing or doing something with Google, or they did something to test the embedding model and decided this is the model we want to use, and now they want to use it but it's all the way over in Google Cloud, and maybe their center of gravity data-wise is in Azure because that's where they started. And then they, acquired a company that already has a product that works, that's using AWS Bedrock. And so rather than reinvent, a wheel, that the company wants to essentially follow suit and use AWS and use Bedrock. So, this can get very complicated, and this is actually not a pie in the sky scenario. This is a very normal scenario. And so it's very important that we understand that while if this sounds needlessly complicated, like we're just kind of creating this out of thin air, anybody who's worked with the cloud for any period of time understands that this is a very real thing that is happening right now with applications that have nothing to do with AI. And so we're going to add AI to it, and we're going to add things like RAG and these solution pipelines, and it's going to be so much worse. So the requirement then, if we're going to be able to disaggregate these elements, the requirement implied at the network layer for us network engineers is we have to ensure the best network experience between these elements. It has to be gold. So one of the drawbacks for encrypting a data plane is that IPsec VPN solutions usually have a maximum encryption performance of about 1.25 gigs per tunnel, and it's actually gotten a little bit better in recent years. There's some algorithms out there like GCM where we can get closer to 2, but that's still 2 gigs of throughput, and that's per tunnel. So that's because all of the virtual routers utilize a single core per tunnel, and this is an IPsec limitation, right? This is a technology limitation. So the way IPsec is built essentially, or coded, it's threaded, single threaded, if you will. You can't spread it over multiple cores. So what you end up having to do is create multiple tunnels. And any network engineer will tell you that manually creating a ton of tunnels to get higher bandwidth, and then excuse me, and then threading those tunnels in a way that load balances flows across those tunnels and actually load balances the traffic and routing and all of that, it can get extremely complicated. So what Aviatrix has done, and we have an actual patent on this, is we have the ability to do what's called high performance IPsec encryption, high performance encryption. So the controller, of the SDN fabric actually handles this for you. It actually, between our appliances, it multi-threads and multi-tunnels and builds the whole thing up and does the load balancing and everything, uses all the cores that are available and just does it all for you. So we handle a full multiplex of IPsec tunnels to get you the maximum performance possible per the appliance, virtual or physical. And then we mesh it all together and we handle all the load balancing and everything for you. So that takes the complexity right out of having to up the security and the bandwidth. So what does a solution pattern look like? So when we talk about solution pattern, what I'm specifically pointing out is how would I connect an Aviatrix solution in my data center where I've got data sources and I've got data that I want to move to the cloud or I want to reference via the cloud. I want to make accessible in the cloud. How do I connect it to the cloud using Aviatrix with this secure data center LLM pattern? So you could have so first you could have physical or virtual appliances in the data center. We support either. You could use KVM, ESXi. We have appliances. You would generally put these in the data center. You would put it behind whatever it is that you have that's terminating your direct connect. You can actually terminate the direct connect directly to the appliance if you want. Again, it's more design based and based on how you have architected your network. But we can fit either option, right? Terminate to us, terminate behind us. We could just be part of the flow, whatever it looks like. And then we actually end up connecting, with the DX gateway, the direct connect gateway that is in AWS, and then ultimately up into the cloud to a transit VPC where our cloud appliances live. So what we call our Aviatrix transits live in the cloud, and we'll build a data plane from the on-premises location or the middle mile location, whatever that is, up into the cloud and just go straight over the top of your underlay and give you that secure high performance encryption, right? The DX itself is actually only going to be used to advertise the IPsec endpoint reachability. And that helps us overcome the native cloud limitations of route scale and stuff like that. So, and then because we have this data plane, and it's established over the top, and we're using BGP to share prefixes dynamically, we get much higher route scale and much more dynamic route scale. Okay, so from a carrier neutral facility perspective, the pattern is very, very similar, but I think it's important enough to bring up because a lot of customers have middle mile connectivity to the cloud, right? So instead of having it delivered via provider or something to their own on-prem data center, they're actually using some other WAN, some other way to get to an Equinix or a Megaport. And then, that's where they pick up that direct connect into AWS. So we offer in the virtual marketplace for both of those providers, we have a CNF marketplace, in the CNF marketplace rather, or even in their physical appliances. So if you have rack space in Equinix or Megaport, we can put the physical appliance there, or you can consume what we call Aviatrix Edge, which is our edge, our quote unquote on-prem or out of cloud appliance. You can buy it straight from the Megaport or Equinix marketplace, instantiate it, build it straight there, and own it that way. And then, of course, use the middle mile providers circuit provisioning system to stand up and connect pretty much seamlessly, direct connects or what have you to those edges. And then those edges can be connected to our cloud transit, again, giving you that same experience right over the top and making it extremely easy to build a hybrid cloud networking solution. You could also use internet. If you, for some reason, don't have a private circuit, we can even do internet, where you have an internet circuit connected to the spokes, to the edges down there in the middle mile, connecting into transits that are in the cloud for backup, backup connectivity, maybe, or just cheaper connectivity. It really just depends on your what you need to do. We give you the freedom to do that. Okay, so let's walk through what that looks like. So from a packet walk perspective of establishing our data plane, and so you understand, hop by hop, from a networking engineering perspective, how this connectivity is built from your on-prem to up into the cloud. Okay, so let's start with the Aviatrix Edge. So first of all, of course, behind the Aviatrix Edge is going to be the data source, or a network connected to the data source, whatever that is. That's gonna be the first thing. And so when a packet is, let's actually, that's the next slide. Sorry, the next slide we're going to talk about the actual data movement. Let's just say right now we're just establishing the data plane. So we just need to talk about the connectivity between that transit and that edge. So the first thing, of course, is that when the direct connect is connected in some way via a middle mile router or directly connected to our edge appliance, we're going to connect and establish BGP with the direct connect gateway, or the direct connect, depending on how you've architected this, right? It's just going to be normal BGP, and it's going to be used to advertise the Aviatrix edge network, that point-to-point network where we're going to be establishing the IPsec connectivity, right? The next step is, of course, the DX gateway will populate using the virtual gate, the VGW that's attached to the VPC where the transit is located. The route that's being advertised will be populated into the route table of that VPC. So now the transit in AWS will have a route to the edge that is sitting on-prem, whether middle mile or on-prem directly. Okay, and the same thing happens in reverse, of course. The VGW attached to the VPC where the transit is located in the cloud is also advertising the VPC CIDR to the DX gateway, ultimately through BGP, to the Aviatrix edge that's on-prem. So now the Aviatrix edge is aware, I can reach the Aviatrix transit IP for the IPsec connectivity over this DX because I've got this this thing has been advertised to me. So two-way connectivity, right? That's the main thing. We've got two-way connectivity, and so our return path is complete. So we can get there, a packet can get there, a packet can get back. So now we can build a data plane, and that allows us, because these IPsec endpoints now have reachability to each other, when you attach the edge to the transit using the Aviatrix workflow, our controller, essentially, the SDN orchestration handles oh, well, it knows the transit is here, it knows the edge is here, it knows all the IPs. It just says go make an IPsec connection, and it'll do so using, of course, multiple tunnels, the multiplexing, the high performance data center edge stuff, or high performance encryption we just talked about. It'll multiplex all those tunnels and everything. It's just going to build IPsec connectivity between these two endpoints. Okay, and so now we have a high performance encrypted tunnel between these two endpoints. So let's talk about the data path. So from behind the Aviatrix edge, we now have, say, a data source, and we need to get, that embedding model that we have, say, in AWS, or is going to need to, chunk the data that's pulled from the data source. So we need connectivity, and it has to be high performance. So from a packet walking perspective, first, that packet's going to come from the on-premises router or middle mile router if it's in a colo, whatever that looks like. It's going to go to the Aviatrix edge, and the Aviatrix edge, of course, is going to encapsulate it in one of the say single flow, right? Say this is a single flow. It's going to encapsulate it in one of the high performance encrypted IPsec tunnels, and then that tunnel, of course, the other side of that tunnel is an Aviatrix transit. So it will be delivered over that IPsec tunnel to the Aviatrix transit, and then the Aviatrix transit is actually connected to whatever you have as a customer, whatever you've built, whatever the cloud network that you already have built on the other side. Usually it's going to be something like a cloud WAN or transit gateway or something like that. And the Aviatrix transit is going to be connected to that. Like, again, it's going to be TGW, or, for the newer customers, it might be cloud WAN, it just depends, using IPsec Connect, like VPN Connect, or GRE, using TGW Connect. So we fully support connectivity using both options to TGW and Cloud WAN. So yeah, so you're gonna that packet will get to again, either TGW or Cloud WAN or whatever, and ultimately onto the workload. We do have the ability to do what are called Aviatrix spokes, and we could replace the entire process, but that's not really part of what we're talking about today. It's what we're talking about today is really like, how do we accelerate your connectivity and make your connectivity better and more uniform from your on-prem to the data center, or from other clouds to the data. On-prem to the cloud, or other clouds to AWS. So what's great about our solution patterns, though, is we do have the ability to essentially rinse and repeat this solution pattern across any cloud, right? So obviously each cloud does their private circuits very slightly different. Like, for example, with Azure ExpressRoute, their workflow for creating the ExpressRoute is slightly different. But from a connectivity perspective, right, we're ultimately only interested in getting that IPsec over the top connectivity, so we get that uniform experience and route scale and security and everything. So that solution pattern is repeatable across any number of clouds. And then once you've done that, you can actually move packets over the private circuits between clouds using the, paying less egress fees and everything. Or as a backup, we have the option to actually connect those transits together. Now, that's using the internet. It would definitely be better as a backup option for this kind of solution pattern. But we offer the option. So if you lost one of your direct connects, you even have the ability to keep connectivity going. All right. So the connectivity is great. The unified network is great. All of these things are great. But what do we get out of having a unified cloud network? What is the actual benefit? Like, that's a lot of, it could seem like a lot of trouble to go through just to solve a single problem. Of course, we don't solve one single problem, but we're specifically talking about the RAG solution, RAG pipelines today. But what else do we get? So obviously the first thing is we get a uniform experience. And I've mentioned this several times throughout the talk. The point of Aviatrix is to give you a unified networking experience for all of your critical applications across any number of clouds, across hybrid cloud, the data center, to get it all connected, get it all look the same, and all managed the same. And because of that, because we're in the data plane, you get the enhanced visibility and troubleshooting capabilities, right? When we're talking about things like an AI workload solution and like a RAG pipeline and other critical business applications, you don't want to have to correlate a bunch of different locations and a bunch of different logging and troubleshooting capabilities across multiple vendors, right? We've stitched together a network, and now we have all these different dashboards. We've got CloudWatch, we've got Azure Analytics, we've got SolarWinds on-prem, right? Like, it would be really good to be able to do application layer visibility and troubleshooting for your critical business apps, um, in one place, essentially in one place and using one data plane. And then, of course, because, as I mentioned before, because we're unified across the whole cloud, because we give you that uniform experience, because we are in the data plane, this also lets us do a single security policy, right? So instead of having to manage 40 different firewalls, or manage, a smattering of native firewalls, or different kinds of firewalls in each cloud, and policies in each cloud being different, you actually have the ability with our controller to build one policy and have it enforced in any cloud using cloud-aware criteria, right? So CSP tags, what cloud am I in? You could use that as criteria. What region am I in? Like, those kind of, you can get really, really granular with it, and push that single policy out across the whole network and have it actually enforced where the workloads are, rather than having to pull data that, pay for data transfer charges that might ultimately get dropped. So that's another powerful thing that we offer. Okay, so from a network insights perspective, what are we talking about here? So network insights help you understand how your network is performing. This is a feature that we have. It's an API. It's a telemetry API feature that we have. So we have integrations with visualization tools like Grafana and like New Relic. And these give you network layer visualizations of how your network is performing across all of the clouds and across hybrid cloud. Again, that single data plane allows us to present a view of your network, right? So if you think, from going back to the whole reason we're here, which is to talk about RAG, if you disaggregate your RAG, for whatever reason that you might have to do so, that's a lot that can go wrong potentially in between those workloads. And so the ability to visualize and troubleshoot the pieces between in a single place, and see the performance, and see how the application is performing from a network perspective, that's really powerful, right? And in addition, we see things like BGP status. Is BGP up? Are we receiving routes? Are our tunnels up? And also, hey, are our gateways, are our Aviatrix gateways being overutilized, underutilized? Is there an opportunity to do some cost optimization, there, for example? Or, do we want to make things better by upsizing our gateways? And all of that is kind of visualized for you. And then, of course, as I mentioned, being in the data plane allows us to give you the ability to do security at scale, and do security where you want to do security. Part of the reason we centralized security in the first place years ago was because of the management aspect, right? If we had been able to have our druthers essentially back then, what we would have done probably is something like this, where we want the policy to be made in one place. We want the management to be done in one place. We want the enforcement to be done where the enforcement should be done, right? So something that traditional firewall vendors do, even the ones that centralize their management, struggle with, is the idea of a one policy that is enforced in a piecemeal fashion, right? So one of the powerful things that Aviatrix, distributed cloud firewall brings, is that you can build the policy in one place, and every single gateway is not going to get 3,000 firewall rules. Let's say you build a policy with 3,000 firewall rules. Every gateway is not going to be sitting there chunking through 3,000 firewall rules. The rules themselves will be placed and enforced in the areas of your cloud network where they should be, right? And the other thing that allows you to do is save on egress charges, save on data transfer charges, because you no longer have to pull data to a central location for inspection purposes. So you're not paying for data transfer for something that you ultimately end up dropping anyway. So I think it's a really, really powerful capability that we have, and it's something that we offer, and it just makes this entire thing better. All right, so let's recap. Right, we're coming to the end of the presentation. Let's recap what we've talked about and kind of where we should go from here. So again, RAG is a very important technology. It enriches, it improves, it makes more timely the results of using a large language model. So we can use a large language model, but we want it to be able to use new data. And we not just new data, but maybe proprietary data, right? The large language model is, hopefully, knock on wood, not going to have proprietary company information that you may want to be part of the consideration of the output that comes out of a GenAI solution, but you want to protect that data, right? You don't want to just feed it. You don't want it to be used to train a large language model where anybody can use it. You want to use it yourself and not have it exposed. This is the point of RAG. So Amazon Bedrock, again, is a managed front-end service for foundational models that uses an API, right? So Amazon Bedrock is not an LLM. Amazon Bedrock is a front-end API managed service that allows you to use the API of Bedrock to do all the back-end connectivity to the LLMs that they've already built for you. And then, so for some customers, that may make sense. Just use Amazon Bedrocks with their knowledge base, right? Use the pre-canned, pre-built knowledge base solution, choose from the drop-downs, and just leverage the RAG solution that AWS is making available to you as part of Bedrock. And for some customers, that is all you'll need to do. If you need granular control over any pieces of this, and by granular control, I mean for reasons like regulatory reasons, for policy governance reasons, for just business reasons, right? Your center of gravity may not be in AWS. For whatever that, your center of gravity may be on-prem or in a different cloud. Or your vector your vector database might be somewhere else. Your embedding model you might want to use an embedding model that AWS doesn't offer as part of knowledge base, right? There's lots of reasons why customers might want to use a different, build their own solution. And then, so from creating a unified, high-speed, secure network to connect all of these pieces together, that's critical. That is absolutely critical to making the whole thing work. You just cannot be successful with a disaggregated AI solution pipeline, RAG or otherwise, without a highly performant network. And so this is the part that I really want to drive home, right? If you are designing, whether you use Aviatrix or not, if you're going to design a network that's going to have disaggregated solution pipeline pieces for, like I said, either disaggregated RAG or some other pieces disaggregated, a performant network that you understand and that you can troubleshoot and that you can operate, absolutely critical. It's not negotiable. So, and if you'd like to learn more about our solution, please request a demo. You can join AWS and Aviatrix on one of the immersion days that we have. We have them pretty regularly as a partnership with AWS. And of course, please check out our ACE program, which is our Aviatrix Certified Engineer program. You can, of course, scan the QR code, or you can drop by our booth. We're going to have a booth at AWS reInvent. You can find it. You can find all the details on our webpage. You can even, I believe, get certified at the potentially at the show. And if not, of course, you can get certified after. We have lots of options there. So I want to thank everyone for joining, and I look forward to connecting with you at a future date. I hope you had fun.